Did you know that the south pole of the moon is the most challenging part to land on? This region had remained devoid of sunlight for millions of years. Previous attempts, such as Israel's Bereshit mission in April 2019, India's Chandrayaan-2 mission in September 2019, and Russia's Luna 25 mission in August 2022, all met with unfortunate crashes during their endeavors. However, a remarkable feat was achieved on August the 23rd of this year by India's Chandrayaan-3, as it defied the odds and made a soft landing on the south pole of the moon. This achievement carries immense significance due to the formidable conditions presented by this polar region: rugged terrain and bone-chilling temperatures owing to prolonged darkness. But you might wonder, why such obsession with landing on the South Pole if it's really the toughest region? What's so special about this part of the moon? Welcome to the door to the universe. In this video, we will investigate why India just landed on the moon and look for answers to all those questions. For more exclusive updates on space exploration from our channel, don't forget to subscribe and turn on the notification bell. The Chandrayaan-3 spacecraft carefully descended for 19 minutes and finally landed at 8:32 a.m. Eastern Time. After a short wait to let the dust settle from the landing, the main Vikram lander smoothly released the Chandrayaan rover. This event was a big step for India's space exploration under ISRO's leadership. Reports from the ISRO ground team said that both the lander and rover worked well. The Chandrayaan-3 mission had two main goals: to make a safe landing on the moon and to show that the rover could work well on the moon's surface. India's ISRO wanted to explore the moon's south pole to learn more about its materials. Scientists wanted to find out if there was water ice hidden in dark craters at the south pole. Getting water from these icy places could help make drinking water, oxygen, and hydrogen that could be used as fuel for powerful rockets. The cold temperatures in that area would keep things frozen for a long time. There's also a lot of interest in the possibility of finding methane and ammonia there, which could be really useful for future missions involving humans. Remarkably, the lunar South Pole is home to the South Pole Aitken Basin, an immense impact crater that is the moon's largest. The study of this basin can offer invaluable insights into the moon's evolutionary history. If that's not enough, the significance of the lunar South Pole extends to the realm of radio astronomy as well. Earth's radio interference has hindered exploration of the electromagnetic spectrum below 30 megahertz. However, this obstacle can be circumvented near Malapert Mountain on the moon. The Vikram lander, carrying a thermal sensor for temperature measurements and assessing lunar soil's heat retention capacity, also featured a seismometer to detect moonquakes and a Langmuir probe to measure plasma density near the surface. Because the moon doesn't have much air, its surface gathers a slight charge, causing a rare event where plasma forms. At the same time, the Chandrayaan rover, which had 6 wheels, had tools to examine the makeup of the moon's surface closely. It had a machine to study the elements in the moon's soil using X-rays, and another tool that used lasers to study the minerals in the ground. All of this happened in a short time, which is 1 day on the moon equal to 14 days on Earth. After this time, when the sun moves away from the moon's south pole, darkness covers the area, and both the lander and rover get frozen in place. Significantly, the Chandrayaan-2 orbiter played a pivotal role even before the Chandrayaan-3's launch. It circled the moon, capturing images of the designated landing site and employing its suite of instruments for tasks ranging from mapping terrain to detecting water molecules. Recent attempts by other groups like iSpace's Hakuto R and Russia's Luna 25 highlight the difficult problems that come with landing on the moon. Out of all the countries in the world, only 4, the United States, former USSR, China, and now India, have been able to achieve the impressive accomplishment of landing on the moon. Then what helped India beat all other nations, including Russia? The lessons learned from the failure of Chandrayaan-2, which involved fixing problems with the engine's power and accuracy, were crucial for the successful journey of Chandrayaan-3. The detailed study of Chandrayaan-2's lander report in November 2019 helped with the careful planning and execution of the third mission. Chandrayaan-3 took a longer route over a month to save fuel and focused on a careful approach to landing, which was different from the rushed tactics of Russian Luna 25. Moreover, the insights from Chandrayaan-3 can enhance NASA's Artemis missions, showcasing how India's achievements benefit the global space community. While ISRO took such a giant leap, SpaceX is not far behind either. The static fire test for Booster 9 unfolded successfully at the Starbase Boca Chica site on August 25th. Despite the premature shutdown of 2 engines, the booster's 33 Raptor engines roared to life for a full 6 seconds, marking a substantial improvement compared to the prior static fire test on August the 6th, where the SpaceX team terminated the trial after merely 2 seconds due to engine cooldown issues. SpaceX's captivating visuals showcased the test from multiple angles, emphasizing the deluge system's containment of shockwaves from the 33 engines. The force of 3,600 tons instantly vaporized and expelled water, yet the system remained intact. There was significantly less dirt or debris thrown around, and the metal plate under the booster didn't get much damage. This shows that the deluge system worked well as a test, probably the last one before the Booster 9's real test flight. SpaceX did many tests to make sure everything worked. They checked the pressure, started the pumps, tested the engines twice without moving the rocket, and added a new part called the interstage vent ring for the next test flight, where the rocket would fire while staying on the ground. They did a lot, except for some interference from the FAA, the government agency that oversees aviation safety. Though the results from the test on April the 20th haven't been shared yet, it's not just SpaceX's job. They gave a detailed report about the accident to the FAA on August 15th, and the FAA is now studying the report to reveal what SpaceX needs to fix once they're done. This might take a while because the FAA is very careful when it comes to things that can explode. SpaceX and the FAA have previously collaborated on environmental checks for rocket tests, aligning with SpaceX's Super Heavy launch plans for important government missions like Artemis 3. Booster 9, too, seems ready, and launch facility improvements are working great. If things go well, SpaceX's efforts might speed up FAA authorization. Although the timeline could be extended a bit, Booster 9 is definitely ready for flight. In a separate development, the European Space Agency, the ESA, is about to embark on an ambitious initiative to rid low Earth orbit of rocket debris. Nevertheless, it has its own difficulties. In 2020, ESA entered into a contract with ClearSpace SA, a Swiss startup, to construct a spacecraft for the pioneering space debris cleanup mission named ClearSpace 1. The primary objective of this vehicle is to demonstrate a methodology for safely deorbiting debris through the utilization of 4 flexible arms, coupled with LiDAR, radar, and camera systems. ClearSpace 1 is engineered to attach itself to a designed piece of debris and facilitate its controlled re-entry. The intended target for this mission is a 2-meter diameter payload adapter for the 2013 Vega VVO-2 mission, weighing approximately 113 kilograms. Payload adapters typically serve as mounting interfaces that allow satellites like the Provo 5 satellite to connect with a rocket's upper stage. On August 10th, the U.S. Space Force told the leaders of a space mission from ESA, the European Space Agency, that they found more space debris near their intended target. It seems that something hit and damaged their equipment. Small pieces of space junk often crash into each other in space, but when they're not heavy, it's usually not a big problem. However, this time the collision messed up the mission's path and added more trash to space. The ClearSpace 1 mission was supposed to start in 2026, but now they need to find a new target and adjust their plans because of this collision. This shows that cleaning up space junk is tough, but it's also important to do. More junk in space means more chances for things to crash into each other, which can harm our satellites and space stations and make it harder to launch new vehicles. ESA is the first group to take action against this problem. They made a deal with companies like Airbus and Thales Alenia to get rid of space junk. This is a big step to keep our orbit safe. The U.S. Federal Communications Commission also updated its rules to require satellite operators to plan to remove their junk within 5 years. Even though some experiments have been done to clean up space junk, progress has been slow. Space junk is hard to control and risky. And ironically, the efforts to clean it up can sometimes create even more junk. The scientists are going to build new space stations and do more exploration in space soon. They just need some brand new goals now. So what do you think the future holds for India's space endeavors? How might all these missions inspire other nations to reach for the stars? Join the conversation in the comments below. Don't forget to subscribe for more space updates and thought-provoking content. Thanks for watching.